So just to save time, we'll be going straight into the hands-on section where we'll be seeing A/B testing, trying to understand the whole concept of A/B testing. I'm just going to share my screen now. Okay, so our practical session will involve us designing and analyzing a case study with Python. I know where I was supposed to put it as a prerequisite for you to have your VS Code and all that, but I really didn't want to scare people. I wanted people who, even though they don't have coding experience, to still listen to the conversation. So we will be using VS Code for this section, but if we don't have it, don't worry about it. Just understand what the concept is about, what the expectation is, so that when you eventually get really settled in your coding aspect, really when you're looking at the programming side of data, which is the data science, the machine learning, the AI part, and all those stuff, you'll be able to understand this. So I don't know if anyone has heard about A/B testing, but it's a very common concept. If you work in any industry, to be honest, and they are involved in things like products, or it could be physical products or online products or all of those things, people would conduct A/B testing. So A/B testing is a controlled experiment. We have two versions. So let's say in an e-commerce like Ali, maybe Amazon UK, want to change something about maybe their checkout points. Maybe they want to put um, recommending other products before checkout, or allowing people to check out before recommending the products. So they build two versions of that, and they say, okay, we can't just dump it on users, because when you dump things on users, you can end up losing customers. So they say, okay, let's observe how users react, how our customers react to two versions of this, and then decide if we're going to go for version A or version B. That's in the case whereby two versions are being proposed. Sometimes there could even be just an existing version, and Amazon wants to introduce something new, and they say, okay, let's see how our users react to this new thing. Let's not just enforce it on every one of them. So what they do in that case is that they randomly assign what different users um, get to experience. So both of us, like me and one other person sitting down here, can be asked, can put the same link that we want to buy the same thing. But what I will see, the version of the e-commerce site I will see, will be different from someone else. Even for physical products too, they may be wanting to introduce something, maybe improve a product by adding maybe more sugar or more salt to it, and they want to see how customer reacts to it. So one person can buy the same product and just have the existing one. Another person can buy and it may just be the new one. So with that, they start taking records, they start capturing user behavior. If it's an e-commerce site, they start capturing user checkout, revenue generation, if there's an increase in revenue, and all of those things. So that's just basically what A/B testing is. So anywhere that's in that they are data driven, they need to make decisions based on data. You get exposed to A/B testing, or where they see to increase return, because if you add something and your customers react negatively to it, you can quickly manage it, you get, because you've observed it, you've compared both performance, than when you now invest more money on the new products and your customers are like, they don't want this, and you end up losing your customers. So this gives you the opportunity to test your market, your customers behavior, before going up. I don't want to spend too many time there. So the concepts you'll be hearing a lot in A/B testing is the null hypothesis. So before now, I used to struggle with understanding what is null and what is alternative. So null hypothesis is saying that whatever change, in a layman's language, is saying whatever change you've made, it has not made any difference. The versions are the same, the two of them, the existing and the new thing you've done has not made any impact. Nothing has changed here. There is no revenue growth, there's nothing. You can as well just remain in your existing state. Whereas the alternative is saying that, oh, this new version is either different from the old version, or this new version is better or worse than the old version. So the two types of alternative hypotheses we can have is that the first case could be saying that the old version and the new version are different. Bias, another case may be saying that the old version is better than the new version better than the old version, or it is worse than the new and the old version. This now deals with either a two-tail test or a one-tail test. So if you're saying, if your focus is not whether one is better than the other, then we're talking about a two-tail test. That is, you're saying that there's a difference between the two. I don't know if it is better or worse, but there's a difference. But if we're saying that one is better than the other, that's where you're focusing your test on, then it's going to be a one-tail test, which I would explain as we go further. So metrics to measure. So depending on the business objective that we will see in our case study, this allows us to define what your primary metrics is. Like, what are you measuring for? So if let me just go straight to the case study. If we look at this case study, this CEO is saying, we have built an app. We want to advertise this app to content creators using Instagram. That is, our target audience are content creators on Instagram, that we've built this app. You know, on Instagram, you can select if you want a generic or if you want to target a particular user segment. And some user segments tend to charge you more. So we have two of that. We have been doing generic advertising and also premium, user specific, user targeted advertising. But it costs more to advertise to a particular set of individuals. They call them premium customers. So your CEO is wondering, okay, is it even worth it? Can we just stick to this generic one? Is there a difference between these two mode of advertising? Because one is costing us more than the other. So with this, based on what this your CEO has told you, you're able to now define, okay, what is the business objective? And you can see here that the business objective is to know whether there is a difference between difference between advertising to the generic content creators or advertising to the premium content creators. This business objective now defines the kind of test, if it's going to be a one-tail test or a two-tail test. If my business objective is that, oh, the premium user advertisement is better than the generic user advertisement, that would be a one-tail test. But now I'm even saying, let me even check first if there's a difference. I can decide to explore something, but let me check if these two things I'm doing is making a difference. So I don't know. I want to know, does anybody have issues with VS Code in this conversation? Do we have anyone who is struggling with VS Code right now? Because I want to move to VS Code. So when you move to VS Code, I'll share my screen just now. Although I've created a slide for anyone who wants to pick it up later. And I've also, here is my GitHub, whereby you can spool it, you can download it and also play around with it. So yeah, just give me. So yeah, I believe, yeah, you can all see my VS Code. The data is gotten from Cargo, and the limitation of this data is that it's already summarized. So you can't really do much in terms of calculating the sample size and duration, but we can still do something with it. The first step, even though I've written all of the code because it's 30 minutes and I want to keep to time, is to download your libraries, which I'm only using 3 libraries for this analysis. And as some people prefer doing statistical analysis to direct machine learning because, I don't know, my boss and I were having that conversation as to which one will give us our results. But yeah, just simple statistics to be able to compare if we are actually investing our money in the right direction. So you download your pandas, your numpy, and your scipy, which contains all of your tests, your statistics, anything that involves statistics. It's right there. So my primary goal, like I said, is to know whether the test campaign, that is the target audience, is giving something different from the generic part. You bring in your data using pandas. When I brought in my data, I realized that the column names I'm not comfortable with them. I like to understand my column names and all of that. So I renamed my columns. The next thing that I always advise people to do whenever they're working with data is to check if they are missing values. That is more or less like preparing your data. For the first one, which is the test campaign. So when I say test campaign, that is the ones that are specific, user segmented campaign. There is no missing value. But for the ones that are the control, which is the generic one, we have missing value. So whenever you encounter missing value, the first thing you want to do is to know if it is missing by random or if it is missing specifically. So I bring out that particular date, if it's a particular date, to know if, okay, this particular date, to know the dates whereby we have the missing value. And with this, I'm able to see that this thing is not missing by random. It's just one particular date, and that particular date, certain information were not gathered. So in this case, it's not missing by random. It's actually missing specifically. And if I leave it on the control campaign if I take it out of the control, I also have to take it out of the test to avoid bias. That means for that day, both on the control and on the test side, the data will not be included in the analysis so that we will avoid bias. So I've taken it out just as we've seen here. All of this is just the data pre-processing. It's not really where the statistics come into place. That's the only cleaning I did. But probably when you play with the data, you'll be able to see what other thing you need to include. So then we come to the main statistical part, which is significance of a test. So on my slide sheet, I try to define when I say the significance of a test, what it really means. And significance level is the probability of rejecting the null hypothesis when it is true. So usually in data science, we tend to put it at 0.05, which is 5%. So we're saying that, okay, we are giving a 5% allowance to the system, to the let us call it a system, to reject the null hypothesis when it is true. And remember, our null hypothesis is saying that there is no difference. The two of them are the same. So we're leaving it at 5%. But if you're dealing with things that involves the medical line, whereby saying there is a difference when there's no difference can result to loss of life, you tend to make it stricter and you put it at 1%. So if it's something that involves two medicine, maybe version A and version B medicine, and you are comparing, you work in the medical lab, I will always advise you to put your significance level at 0.01. That way it's stricter. The confidence interval is just 1 minus the significance level. So if the significance level is 0.01, the confidence interval will be 99%. In a layman's term, the whole confidence interval, when I define it, is saying that I want you to be 99% sure before you reject the null hypothesis. That way it's stricter compared to when I say, okay, be 95% sure or be 90% sure before rejecting the null hypothesis. So when it comes to statistics, you need to think about the consequences of selecting certain values. Then your p-value, I don't know if you've heard that p-value is just what allows us, is the result that we interpret to know whether we should indeed reject the null value or we should accept it. So if your p-value is less than your significance level, you reject the null hypothesis. And what does that mean? It means that you say, yes, indeed, there's a difference between these two, between the new version and the old version. But if the p-value is greater than the significance level, then you're saying, no, there is no difference. They are the same thing. And then the business can make decision based on that. If they should keep paying money for premium, whereas it's just giving the same, whereas they're just giving the same results. Since the CEO in this case study is really his focus is saying, okay, this advertisement, are we getting more people to click? Are we getting more clicks to our website from this advertisement? Are we getting more clicks to where you can download this app from this advertisement? Therefore, what we are measuring is the clicks. Is if what is saying, if that is said, oh, are we getting more people downloading this website, then we will not be focusing on the clicks. We'll be focusing on the number of downloads. So whatever is the business focus influences what you measure. Sometimes the business may say that, okay, we want to know unique click, like it's unique users, not just. So if I get the advertisement 5 times and I click 5 times, they only want to know one, which is me. But sometimes the business can say the 5 times I click, they want to know, they want to measure that. In this case, I'm measuring the 5 times I clicked. So that will be the mean of click. But here the business says, oh, we want to measure individual, like unique clicks, then it will be click-through rate. Click-through rate is number of clicks divided by the number of impression. Impression is number of times the user sees it. Then number of click is number of times user click on that advertisement. If you are having difficulties, don't worry about it. You can always reach out to me, because we obviously cannot cover everything in 30 minutes. So with that in mind, I'm able to now form my statistical hypothesis, which says the mean number of clicks generated by the targeted campaign is equal to the mean number of clicks generated by the generic campaign. That's my null hypothesis. So my alternative hypothesis is saying that there is a difference. So in this case, I do not need all of this column. I only need the clicks, which is this one, to do my analysis. So once I've defined my null and alternative based on the business goal, since my primary metric is the mean number of clicks, it's a numeric metric that would influence the kind of test I want to do. So you first of all, you have to define your metric, which what you want to measure, and then decide if it is categorical or continuous. So since mine is continuous, the kind of test I will do will be a T test or a Z test, or tests that are for continuous, like ANOVA. I also define my sample size. This cargo data cannot really show us the sample size breakdown, but we can just assume, since they captured it for 30 days, we've removed 1 day, that is 29. We'll just say, let's just put it as the sample size is just 29. But it's definitely going to be more than that, but it's not a breakdown. So we can't we'll just assume that it's 29 days, which means it's less than 30. Because it's a small sample size, less than 30, it's also continuous, want to be looking at a t-test, using a t-test. If it was more than 30, that is a large sample size, looking at a z-test. But then again, t-test is different. We have the Wellish t-test and the standard t-test, which involve pool variance. What makes these two different? When you are working with two groups, that is like now we're working with the targeted and also the generic, we'll compare the variance of the two groups. If the variance of the two groups are equal, then we'll use the standard t-test. If the variance of the two groups are not equal, that when we use the Wellish t-test. Like I said before, all of this are on the GitHub repo, and you can always like take it and read it up. But your test is, like I said, is influenced by the type of data, the sample size, the comparison of the variation between the two groups. So what do you use to calculate the variation? You use an F-test, and you use F statistics to compare the variance, between two groups. And the type of F statistic you use is Levenis test. Although it's not the only one, but it's robust enough that even if it's not equal, it can detect it. So you don't need, like I always tell people that I kind of cheat coding. You don't have to cram everything. You just need to know what the we call it algorithm, like the steps to take. There are resources online, but if you don't know it, you don't know it. That's the honest truth. But if you know what the steps to take, you can know what to look out for when you go online. So by performing this Levenis test, we're able to know if the variance between the two groups, this is our group 1 and this is our group 2, if they are equal. So what it's saying here is that we have equal variance. And like I said before, if the variance are equal, then you just go for the standard t-test. But some cases they may not be equal. And in that case, you go for the Wellish t-test. So since we know we're going for the standard t-test, and we also know that because we are comparing between two groups, because our alternative test is not saying maybe one is better than one, so it's going to be a standard two-tail t-test. So based on our alternative hypothesis, where we are measuring where we are saying they are different, when we want to check if they are different, we're not just focusing on one. We're also seeing that, the variance are equal, is a small sample size, and what we are measuring is also continuous. So we'll be using a two-tail standard t-test. To calculate the p-value for a t-test is different from that of a one-tail. For a two-tailed test, therefore that of a one-tailed test. And the formula is, I will never tell you to cram the formula, to be honest, but just know it enough that you're able to explain your code. So to calculate the p-value for the two-tailed test, you will need your degree of freedom, you will need your t-statistics, and you cannot get your t-statistics without getting your pool standard deviation, which you get from your pool variance. So all of this whole part you see here, the calculation is just done to feed into the formula for calculating the p-value. So you don't need to cram anything. You just need to know that, okay, this is the formula for calculating p-value. And I need to get the pool variance, the pool standard deviation. I use it to calculate the t-statistics, and I also need to calculate the degree of freedom. Degree of freedom is calculated no matter what kind of test it is, even if it's a continuous a categorical metrics, you will still calculate your degree of freedom. So even if you're using chi-square, even if you're using z-test, or even if you're using t-test, you still calculate your degree of freedom. So once you're able to get that, you just fit it into your p-value calculation. And like we said, our confidence interval, we kept it at 95%. But I remember I said that it can be 99. It depends on how strict you want it to be. Like, yeah, we are dealing with medicine or something that involves, like, it costs a lot. So with the confidence interval and also the p-value, we'll be able to get our upper confidence interval and our lower confidence interval. Said again, you don't have to cram the formula, but if you're having difficulties with the formula, you can always reach out to me. So with this in mind, knowing my p-value and knowing my confidence interval, which is my lower and upper confidence interval, I can now decide if this difference is significant or not. Since my p-value is since my p-value is 0.1, but my significant level is 0.05, which means that my p-value is greater than my significant level that I've chosen. So in this case, we will not reject the null hypothesis. So since we're not rejecting the null hypothesis, we're saying that there is no difference between the two groups. Then the confidence interval allows us to know the practical difference. The p-value allows us to know the statistical difference, while the confidence interval allows us to know the practical difference. So if your confidence interval comes out like this, whereby you have the lower band is on the negative side and the upper band is on the positive side, and there's like a zero in between the value, you will also not reject the null hypothesis. If there's a zero between your lower band and your upper band, you won't reject it. That means you're saying that both cases, practically, there's no difference. And also statistically, there's also no difference. That's just basically it's as simple as this, as straightforward as this. You don't need to cram the formula. I don't think anyone in particular, I've watched different interviews that involves A/B testing. No one will ask you to cram the formula. They just want to know your chain of thoughts. That is why did you choose two tail tests instead of a one tail test? Why did you choose t-test instead of a chi-square test, and all of those things? So so for both the first one and the second one, do we have any question? So for our two sections, do we have any question? Do you have any question you want to ask Mr. Peter? Do you have any question you want to ask me?